Welcome back to Cloud AI Nexus 360. In episode 1, we essentially showed you the vision and sort of a live demo of what we have built so far in relation to log search. Today, we're going to be diving deeper into AI Agents Explained, Tools Planning, and the MCP Server. We'll look at theory, research from the likes of OpenAI, Anthropic, and some academic papers, and how we have started to implement some of these concepts in our log search proof of concept. Thank you. In terms of some of the definition framing for this episode, we are going to be looking at three main concepts here. The first one is the workflow agent and MCP server. So some of the broad definitions around the AI agent, it's basically autonomous in itself. It's going to be powered by an LLM. It interprets goals, plans, and produces output. In this regard, we have the responder agent. Much later in a further phase, maybe phase 2, we're going to be looking at incorporating the planner agent that will allow for unstructured requests. We also have the workflow agent, and as we rightly said before, is more deterministic. It's not AI per se. It's sort of rule-based. It's essentially just logic which has been sort of crafted within the workflow. In this regard, in the log search app, we have the hotel agent, which fetches hotel based on integration with a provider, Amadeus provider API. We also have the budget agent, which is sole purpose is to filter and rank hotels based on input by the customer. And thirdly, we have the MCP server, and the MCP server is the orchestrator, or what you could refer to as a glue, which exposes agents as essentially tools via the model context protocol. Typically, an MCP server will have three capabilities. It has tools, it has response, and it has prompt. But on this occasion, we're only going to be the tools capability. It also, in the MCP server, also has three methods as well. And we're going to demonstrate that later in terms of the methods we've been able to craft. Methods around initialization, methods around tools lists, and methods around tools call. So tools are basically actions agents can take. The MCP server will expose them dynamically in log search. We have exposed, this is the code for the MCP server. I'm just going to show you a snippet here of what we've done. You can see from the tool list, we have the hotel search, we have the budget filter, CP server, and based on that, communication is done over based on RPC, and it's essentially going to respond back to the client as to what tools are available. So the agents or the workflow agents here are in terms of the budget filter, the budget agent, and the hotel agent. As we said before, they are primarily rules based, and there's no sort of creativity around them. They are not autonomous in any regard, obviously, but they are reliable. So we'll just go through snippets of this piece of code for you to just have a feel of what's going on. This is essentially the hotel agent, and the purpose of this code is mainly is the main domain logic. Its purpose is to find hotels, normalize the fields, apply business filters, etc., based on the estimates per night price. And optionally, we're going to be the feedback is going to be enriched by Google Places based on further interaction by the Amadeus code with Google Places API. There are things around I/O as well, in terms of the stay, the status, okay, hotels, etc. We also have calls in terms of the tool provider. You can see that there. So all of this, you see the normalization of the hotel, which is called back, um, etc. It has an accompanying handler, and essentially the purpose is to serve as an integration glue, to speak the AWS event dialects, in relation to integration with API gateway, and obviously direct invoke. It also handles CORS, as you can rightly see, and the JSON RPC wrapping or unwrapping. It has some feature flags. It has login and error tolerant HTTP responses. It optionally will be calling a responder narrator to add summaries to its findings. You may ask, why do we have to separate the handler from the main code in terms of the agent? Is the agent itself is mainly the business logic, whereas the handler is serves as a platform essentially for transport. Some of the rationale behind it is to allow for building in sort of small groups, so you're able in small phases to allow for easy experimentation and faster iteration as well. Fewer files, so we don't have elongated code, which we are if you with debugging. So a lot of modularity around the idea here. So this is the budget agent, also deterministic. Its purpose is to rank hotels by GPB price. That is the currency which we are going to be using. If this was to be deployed on an enterprise or SaaS scale, we're basically going to be looking for an API we can integrate the application to, so we're able to see a list of currencies of all, in terms of what the global currencies are, to make our life easier than hard coding those. It prioritizes these hotels based on the user's maximum budget, giving a tiny tie-break boost to places with amenities. But unfortunately, at this point, the Amadeus free tier API we're able to connect to doesn't is not rendering hotels with in terms of details of what amenities they have. So we'll just leave with what we have at the moment. So inputs is hotels, the maximum price, things like the price check, the check-in date, the checkout date, and also things like the status. This is sort of expected, the top candidates, the ranking, etc. It also provides some normalization in terms of the night, the dates. There's sort of a fallback around those as well, if it's missing bad dates. So there's normalization around the nights, there's normalization around the price, and normalization around amenities in terms of the pool flag, etc. It has a filter, So it's going to be ranking candidates. So all hotels are sorted by price first, the cheapest first, a slight bonus if it has an indoor pool. And obviously the output is going to be returning the status okay. So the budget agent has a respective handler, and obviously, as we rightly said before, is to provide a uniform entry point that parses events from multiple sources and calls to run a defined task. It's going to basically understand events from direct invoke and the API gateway, JSON body, handler, which is base 64. It has responses in terms of if everything is okay, we have the response 200. If we have some challenges or issues, it has the 400 if the request cannot be passed. So overall, the orchestrator, which is the MCP server, is going to collect hotels from the hotel agent and passes them with a maximum price and GP and corresponding dates to the budget handler. The orchestrator will then forward the top picks and I think the optional candidates to the responder for the icing on the cake, which is the narration, which we presented on the UI. So we're going to be showing all of that later on in this episode. So we can do like a high-level comparison of the budget agent as well as the hotel agent. As you can see, this is supposed to be the responder agent code, and you will notice that this one is going to be using the LLM. In this regard, is one of the Anthropic LLMs, Claude, to generate natural text from obviously a structured JSON. So what we have here, what is the purpose of this, is it's going to take structured hotel results, obviously the top picks, candidates and context, and turn them into some friendly natural language summary. Think about this as sort of the narrator layer. So instead of the users or the customer just getting plain text or what you might refer to as raw JSON with hotel names and prices, etc., it's the idea this is going to provide some sort of concierge style write-up around the results which have been returned. So we have the template here, and you can see that the template driven prompt should fit along these lines. It says you're a helpful travel concierge. Write a concise, friendly summary in 4 to 6 sentences about the hotel options. We provided some rules at the back of this as well, and we've the other things around this is to provide some compact JSON embedding, and that is to be able to manage the expectation in terms of the size of what the LLM is sort of spouting out. So that is for us to provide sort of a to make the what is returning somewhat shorter, so we're not it doesn't blow up in size. We also have sort of fallback logic in terms of if there are no hotels returned. We sort of put like this there to say I couldn't find suitable hotels yet. Try widening the area, adjusting dates or increasing the nightly budget, I'll search again, etc. We have the LLM call. So the LLM call is to, which is, let me show you where that is. 1 second. So it's essentially to lower the sort of temperature for consistency. We don't want the response to be overly creative in its response. So it's sort of trying to ensure consistency to prevent overlong or overly creative responses. So that is why we've put the temperature to whatever is stated here. And in terms of the size of the tokens, we've sort of restricted it to say 600 tokens. So that is the essence of this particular safeguard here. For this particular responder, we don't have any handlers per se. As we said previously, handlers are essentially service entry points that are invoked via the Lambda orchestrator, which is the MCP server. So the MCP server, as we said previously, it usually has 3 capabilities. It has tools, it has resources, it has prompts. But what we are going to illustrate today in terms of the code snippets, we managed to craft in tools at this point in time. It also has methods as well. So we did say that the methods, we had initialization, we had tools calls, and we had tools listing. Okay, so just to give you like a bit of an analogy, the MCP server is going to serve as a laptop, and you could have like the so-called USB-C ports, which supposedly is sort of a one standard connector for all devices. So you could have these multiple devices here connecting, but they just see, as far as they're concerned, they're just seeing one particular interface which is being exposed to them. So these tools are basically can be referred to as agents, and they are essentially, and they are also the devices. And we did say that you have tools listing, which exposes the tools to the interface at the other side of the API gateway. So the MCP server, it ties it all together. So a client at the back of the API gateway is going to be sending some arguments in terms of a payload, and the essence of this laptop is to normalize whatever is being sent and call the rightful agent. So you have so as we said, these agents are at the other side of the backend, and they're going to respond to whatever has been whatever requests that has come from the front end, which is the API gateway. But obviously we have the MCP server as a glue, what you might refer to as a glue orchestrator. So we're looking at the MCP server code. So what we have here, you can see a host of imports. Some of them have to do with environmental variables, deserialization, as well as error text. You can see the Boto here, that is Boto 3, which is used to invoke downstream lambdas. The downstream lambdas in its context is essentially hotel and budget. They are typing, which is to do with type hints only, and the agent's planner plan, which is going to be utilized at a later date. There are obviously key variables which have been defined, as you can rightly see there. I'm not going to go into those because they are self-explanatory. And subsequently, we do have a bunch of helper functions in relation to the reps HTTP build response builder, the invoke lambda, things like normalize dates to help with normal sort of a normalized utility function, planner handler, pass, stay, etc., etc. So let's essentially focus on the main crux of this particular MCP server in relation to the capabilities which I did mention in terms of tools and their various methods. So we have the first one, which is here. We have the initialize, and as you can rightly see here, you have the initialize. That this is a particular capability, which is tools, and that provides the context of the server information in terms of the MCP server and its version. We also have, so what does this do? What is its purpose in reality? It lets the client know, which the client is at the other side, that the server is up and whether the tool metadata has essentially changed. Okay. In terms of the tool list, we have the tool list is listed here, and you will see that the tools list has a variety of tools like the hotel search, the budget filter, things like planner, etc., etc. So you could see the tools here, this tools list, the purpose is basically to advertise what available tools we have defined in relation to the MCP server and their subsequent JSON schemas, so the UI or the respective agents can validate the necessary inputs. As you can see here, you have the hotel search. I'm just going to go through each one briefly. You have the budget filter, you have the responder narrate, you have the planner plan, you have the plan, you have the planner execute. And as I rightly said, in terms of the planner, is going to be we're going to be looking at enhancing the app in sort of a phase 2 version of this interaction. We also have the tools call. So the tools call is, one second, let me see where that is. So the tools call is here, and its purpose is essentially to execute a name tool and to dispatch parameter names. So you can see the parameter names and the respective arguments listed there. So the tools call is going to return the JSON RPC, and that JSON RPC is there in terms of the hotel search. You can see that there. So if it's so it has a type and whatever the text is going to be, it gives it room to receive whatever the input is, whatever input is generated from the third party. Likewise, if there is an error, we are going to have the you see this is error, which is returned there as well. So if the tool is errored, or maybe there is a missing environmental variable, it's going to return that. So just to recap this in terms of mental model, so you have the client. So the client is obviously a front end of some sort, which interfaces with the API gateway, and the API gateway engages with the Lambda handler using the JSON RPC format. And example is simply an example request, a call to a tool is made, and it's going to be usually in this sort of format, as you can see there. And once that is done, the Lambda handler will call the tool. It's going to run the pipeline, and it's going to return context blocks, and the Lambda handler will wrap that into the JSON RPC. And the JSON RPC is listed. 1 second, let me just search for it here. I'm just gonna do like a quick find. So this is where it is returned. So this is when it is okay. So this, we have a positive result. The other things that are highlighted is when you have error in terms of maybe an invalid request, or say the particular method is not found. So you have error 400 for invalid request, error 4 as well as for method not found, and we have the response code of 200 if everything is okay. So we have this thing about the planning, which I did say that we're gonna face that incrementally in relation to the development of the application. So, or in the first phase, is simply the front end is calling the tool separately, but in relation to agentic workflows, we're going to see how we're going to introduce the planner execute as part of the capability to allow the user to input their requests in relation to location, budget, etc., instead of like a classical prompt from the front end, as opposed to the manner in which we have the layout, which is somewhat structured today. So that will allow for a one-shot flow in terms of a plan, interfacing with hotel, interfacing with budget, and interfacing with the responder. I'll just give you like a little snapshot of the code that is going to be. So the future vision in terms of the planner will be that the planner agent will live in the agent planner.py. That's essentially where it's going to be. It's going to its plan query function will provide a saved and ordered list of agents. So as we rightly said, we have the hotel search agent, the budget filter agent, and obviously the responder narrate agent. And it will not invoke a Lambda or tools. It just decides on what should run. Okay. So conceptually, the planner execute handler is inside the MCP server, and that's that planner. The planner agent is will have the responsibilities I've mentioned earlier. The MCP server planner execute handler is going to live within the MCP server itself, and that will obviously when an MCP JSON RPC request is made or it comes in with a particular method, possibly the planner executes, this handler will run accordingly. And it is going to use the planner output indirectly. That allows the order, obviously the order which we mentioned before, which is the hotel search, the budget filter, etc., etc. And the whole idea is to match what the planner has defined, and then it will actually execute the invoke hotel function as well as the invoke budget function, chaining the outcome and the results accordingly. So just sort of a run through, the planner agent is going to be defining the recipe in terms of the sequence and the accompanying constraints, whereas the MCP server will execute the handler is referred to the cook or the conductor that runs the recipe against the Lambda tools. So this is just to give you like an analogy of how the whole pieces are strung together. We're building it as we go along, so you're going to be seeing a lot of iterations, as you can see. So essentially, the planner agent will be run by the planner execute handler, which is defined in the MCP server. So just to give you a run through of what's going to happen, the planner execute handler has a number of arguments. Is going to accept the query, a stay object. So if only the query it derives a stay via the pass stay from query. So it's going to do some normalization in relation to dates, so that the downstream lambdas always get the date in a particular order or format. It's going to call the planner through the planner handler to get the agent and the nodes. So there's going to be some ordering of nodes. It's also going to carry out a variety of tasks or invoke a variety of agents in relation to the hotel search agent, the budget filter agent, as well as the responder agent, which it tries that from the agent.responder import narrate. At the back of this is the plan is going to return a consolidated result in terms of the status, the nodes, the agents, and obviously top candidates. This is if we are starting with the planner agent is going to be the first of the is going to be part of the sequence of flow. But right now we're not putting that into place. So everything is sort of enabled by the JSON RPC routing in terms of the tools call, dispatches, the planner plan, or the planner handler, and the planner execute to the planner execute handler, and the lambda handler routing the JSON RPC methods accordingly to these handlers and wraps responses via R refs, which is RSP. So the whole idea is that the MCP server is going to be referring to the planner execute to referring to the planner to decide the order and the respective nodes, and then it's going to perform the actual lambda calls to run the workflow. So that's how that is the future vision of how it's going to string together. But for now, we're not going to be introducing this level of complexity. We're going to do it one step at a time in terms of what we are building. So far, we've tried to utilize a variety of research papers as well as a constellation of industry grounding to back our proof of concept as well as our MVP. The first paper we looked at was Landscape of Emerging Agent Architectures. And essentially what we were able to glean from that paper was it provided some highlights in relation to reasoning, planning, and tool calling as a foundation of agentic systems. We looked at AI agents, evolution, architecture, and that was a paper. Most of these papers are coming from Cornell University, and that provided how agents evolve from rule-based scripts to LLM enhanced architectures, and proposes evaluation of frameworks for real-world deployments. So that was one of the papers we looked at. We also looked at this paper in relation to it's called the Tulip agent. It says enabling LLM based agents with large tool libraries, and that was to show how agents can dynamically select from large tool libraries at runtime without prompt bloat. So we looked at a variety of these. Okay. We also looked at some industry-based papers. One of them, which is quite interesting, was the practical guides in terms of building agents, building them clear, building them safe, having sort of clear goals. That is the paper from OpenAI, which is quite a very good paper. It's very clear, very direct. It gave us sort of a benchmark to use to assess whether what we are building is actually an agentic AI or not, and we're just kind of dipping our feet in the pool, or well, what I would say as just having giving a glimpse of what is possible in relation to the development of LLMs. So based on this definition, we sort of out of a variety of boxes, we are taking like maybe 1 or 2 boxes so far in what we've done or what we intend to do. So that's one of the papers there from OpenAI. There is this one from Claude, which is Anthropic. I think their model is called Claude, and the name of the company is Anthropic, which is quite good. So there's a lot of industry-based attempts, and you will be rest assured that this is an in-flight development. Is not nothing is set in stone. The school of thought on definitions in terms of concepts, terminologies is still evolving as we speak here. 2 of them from Anthropic. One was to do with the model context protocol. Quite interesting papers and worthy of reading. So today we actually looked at workflow agents, the likes of hotel and budget, which are rule-based and deterministic. We looked at an AI agent, a responder, which is going to be powered by LLM, and that matches the definition of what an agent looks like. But obviously the other criteria to make it a fully fledged agent to the nth degree. We looked at planning in terms of chaining tools together, and I think further down the line, based on once we've done or gone into other MVPs which we are going to be developing, we'll look at chaining. We're going to look at a variety of frameworks, maybe LangGraph, LangChain, things like Crew AI, etc. We also looked at the MCP server, which we said was the USB C port of AI, which exposes everything, and it also has like 3 methods. Okay, and I think what we have been developing so far is essentially aligns with academic research and industry best practice from the likes of OpenAI and Anthropic. And in episode 3, we're going to be diving much deeper into the AWS architecture foundations. We have leveraged to deploy the log search. So thanks so much for watching. We'll basically like you to subscribe and like the channel, and also comment and send any comments you have. We'll look at those and feedback to you, and it will encourage us to keep developing our proof of concept further, and that will provide some positive input to what we're doing. Thank you so much.